Hello children, now we are in the discussion of the unit 11 electronics. Without taking much time to greet, I get into the lesson directly. Electronics is based on electricity, electric current. In order to conduct electric current, we use several materials. We call them electric conductors. The most commonly used conductor in our day-to-day electronic circuits is copper. First of all, we are going to study the structure of copper. The structure of copper and how it helps to conduct electricity. For that purpose, I take a simple drawing like this. A piece of copper, and we are going to analyze the arrangement of atoms of the copper conductor. They are copper atoms. When the metallic bonds are formed among metal atoms, the atoms release electrons into this space. It is known as a sea of electrons or maybe a pool of electrons. There are free electrons. I use the blue color to represent the free electrons in these spaces. If a sufficient electromotive force, EMF, electromotive force is provided, these electrons can be sent to this direction if the electromotive force comes from our left hand side. The electromotive force allows electrons to flow through this conductor. When the electrons flow, we call it an electric current. It flows and we call it the electricity is flowing through this conductor. So, a conductor is a material which allows electric current to flow. Is that clear? Then we talk about plastic. You all know that it is an insulator. An insulator, it has no free electrons. When the structure is formed, it does not contain any free electrons. No free electrons. So, it does not conduct electricity. One thing is very clear. If the free electrons are present, it conducts electricity. If the free electrons are not present, it does not conduct electricity. Very simple. The definitions are very clear. The substances or the materials that conduct electricity are known as electric conductors. The materials, those do not conduct electricity, are known as electric insulators. The electric conductors have free electrons in their structure. The electric insulators do not have free electrons in their structure. So, when you answer the first two questions of our assignment, please try to include some examples for those two. Next, in grade 11, we identify another set of materials. We call them semiconductors. Semiconductors, in their name, the definition is already hidden. Semiconductors, the substances, those lie between these two, somewhere around here. Semiconductors, they conduct a small amount of electricity, not as the conductor materials, but they conduct electricity, so we can't place them under the insulator category. Semiconductors. Our main focus on this lesson is about semiconductors. It's time to discuss about semiconductors. A semiconductor has its own structure that helps its semiconductivity. As an example, we take silicon. We all know that silicon has 4 electrons at the outermost energy level. It is a group 4 element in our periodic table. 4 electrons at the outermost energy level. Silicon at 0 Kelvin, this is not OK, it is 0 Kelvin, 0 and K stands for Kelvin. At 0 K, the silicon structure is formed by combining 4 silicon atoms around one silicon atom at 0 K. The electrons, now this silicon has 1, 2, 3, 4, 5, 6, 7, 8 electrons, and the energy share, the outermost energy level is completed and it is stable. Each of these silicon atoms are combined with other 4 silicon atoms. Like that, you may draw it in any extent. In order to make you familiar with the structure, I have included a simple activity to construct this using MS Word or any other software that you like. You can try making a very large crystalline structure that shows the structure of silicon. Let's see what happens when the temperature increases little by little. We know that 0 K, 0 Kelvins is the known lowest temperature. When the temperature increases little by little, I use this symbol for providing external heat energy, thermal energy. The electrons start to vibrate. When they absorb heat energy, more energy, they start to vibrate and break these structures. Some bonds may be broken and there is a gap, and those electrons are released into this structure. Sometimes this one. Now what happened? There are free electrons available in this structure too. When the temperature increases, electrons start to appear. Now we all know that if an EMF is provided from this direction, those electrons can start conducting electric current. Try to think what happens next. If we increase the temperature continuously, what will happen to the amount of free electrons over here in this structure? The number of free electrons increases. When the number of free electrons increases, the conductivity increases. This conductivity is not constant. If we use pure silicon, it increases the conductivity with the temperature. These kind of pure semiconductor lattices are known as intrinsic semiconductors. They are pure. When we increase the temperature of intrinsic semiconductors, they increase their conductivity. Imagine if we use these materials to make or produce a laptop, maybe a mobile phone. Is it suitable? When the temperature increases of this equipment, it increases conductivity. The operations are not constant. When you press a certain button, sometimes it will give a different result when the temperature is high. When the temperature is low, maybe in your area, you may experience a different operation when you press the same button. So, these type of semiconductors are not suitable to produce electronic equipment. In our next discussion, we talk about avoiding this problem. Now I think you have identified the fault of using intrinsic semiconductors in your electronic equipment. The fault is when they increase the temperature, they increase the conductivity. It is not constant. You cannot expect the same result as it is in another temperature.